Hello everyone and welcome to our new Innovation Coffee Break video. My name is Matthäus Urban, I'm the Product Manager for Configuration Lists and Related Products. And I'm here today with my colleague Holger Crisp. Holger, would you like to introduce yourself as well?
Yeah, thank you, Matthäus. I'm Holger Crisp. I'm Product Manager for Control Desk. Today, Matthias and I want to give you an overview about a new key feature in the dSPACE tool chain that helps you to make your workflows more flexible and efficient. It's called SIL Mapping. Matthias, can you please introduce this concept?
Yes, sure. So what is SIL Mapping and why is it interesting for you? So SIL Mapping is basically a feature which simplifies your workflow process of our toolchain by decoupling test automation tools from test benches. And the result is that thanks to SIL Mapping, structural changes in your models do not longer have effect on your test automation tools. The X in SIL Mapping stands for that it can be used in different development stages. For example, it can be used in HIL testing, so hardware in a loop testing, or in SIL testing, so software in a loop testing. So what are the issues and the pain points SIL Mapping solves? So to implement tests, variables are assigned to input and output instruments in control lists and are used in test automation scripts of automation lists. And they typically need an address to write or read simulation variables. And address is provided basically by a variable path. And everything is good and works so far. But if we then restructure our model, the path changes and the connection becomes invalid. And yeah, it's really time consuming and costs so much effort, and SIL Mapping solves this issue. So I have another example here. What can we see here? We have a control desk experiment with a layout showing an instrument cluster with speed and RPM measurement in control list, and also a test case in automation desk and this variable path here for your connections. If you now modify your model by adding another subsystem or solving typing error you made before, layout and data objection connections are lost, and as I said before, SIL Mapping solves this issue. So what's the principle and how does it basically work? We have several steps, and the first step is to define framework labels, which are basically your unique identifiers, and assign those framework labels to your test bench labels, and your test bench labels are basically your paths. And when you make changes, they are automatically adapt to the framework labels. Think of it something like an address book. So you have on the left side your name, for example, which acts as a unique identifier, and your home address on the right side that might change, but your name or unique identifier stays basically the same. So after this, we go to the second step, and now we generate the mapping file by using our simulation generator tools. We can use, for example, Configuration Desk or the Bus Manager. And then in step 3 or 4, we create experiments and test scripts inside Control Desk and Automation Desk and execute them based on the resolved test bench labels. So far, so good. Now we can move on, and I would like to show you the steps in the following demonstration I've just prepared. So we have the Simulink model here, which shows a model of a POTI box, and this POTI box represents our ECU, so our device under test in that case. And it contains several elements, so for example power supply elements, LEDs, switches, and a Viper. And you can also see here that we have some model port blocks here which are already connected to our Simulink model, so we already have a connection between our I/O model in Configuration Desk and our behavior model in Simulink. And the first step is to define and assign the labels. To define and assign test bench labels to the framework labels, we can use this Excel sheet here. As you can see, we have some information here about our framework labels, so in that case our signal names, and further information about units, values, and data type. We have now to open another dSPACE solution, which is called Apple Tools, by typing ds_ta_lib into our MATLAB command window, and then Apple Tools opens, and we can basically drag and drop our TA setup block here into a Simulink model, double click on it, and add a new Excel sheet. After this, we have to drag the get and set TA blocks to our Simulink model and replace them with our Simulink constant blocks and assign them to the corresponding single names. In the end, in our demo, it should look like this here. The second step is to generate our XIL mapping file. To do this, we have to jump into another tool, for example in Configuration Desk, as you can see here. We have already done our I/O configuration in Configuration Desk in our signal chain view. We will now open up the XIL Mapper GUI by going to the Automation tab, clicking on Execute, and then we have to activate this here, Generate XIL Mapping for Configuration Desk I/O function during build process. Save. And now we can go to build and build our configuration. When the build process is finished, we will now see that Configuration Desk generated a XIL mapping file in our build results folder. So Holger, I have created a real-time application with XIL mapping information. How does the journey continue now in Control Desk?
Matthias handed me over this Galaxy real-time application. Thanks for that. I'm now importing it in Control Desk and I use the automatic import option of the mapping file. In this way, the mapping information is also imported to keep it in sync with the real-time application. This is always done when you import a new application or update an existing application. This helps avoiding inconsistencies and simplifies the workflow. Once you have loaded the real-time application and mapping file in Control Desk, all framework labels are automatically resolved to the proper test bench labels. You see that all connections in Control Desk are valid because they can be resolved by help of the XIL mapping. I have a second real-time application in which a subsystem was added in our Simulink model. Thanks to the automatic generation of proper XIL mappings in Configuration Desk, my layout works directly when I import it additionally in Control Desk. When I switch the active variable description in Control Desk, the mapping definition is also switched. By this, I can work comfortably with both different models with only one layout instance.
So this was today's coffee break video with a brief demo of the XIL mapping concept and its benefits within the dSPACE toolchain. In the near future, there will be further coffee break videos that will go more into product details for Configuration Desk, Control Desk and Automation Desk. Thank you for your time and interest. And now, enjoy your coffee.
dSPACE, your partner in simulation and validation.